Embedded Technology Convention. Thank you for having us for the panel discussion today on embedded systems of systems. I'm Tiffany Nielsen, and I will be your moderator for today's panel discussion. And with me, I have David Knight of Turbine. How are you doing today, David?
I'm doing great.
Thank you for joining me. And Johannes Beekman of IoT Marketing. How are you doing, Johannes?
I'm doing great, Tiffany. Thanks for asking, and thanks for organizing this panel.
Absolutely. And again, I'm Tiffany Nielsen with IoT Marketing and Industry Insights webinars. And we are so pleased you could join us today. So to get things started, let's find out a little more about our panel. David, can you tell us a little bit about your background and expertise as the CEO and founder of Turbine?
Absolutely. My background is actually in applied physics, going way back, and I've been involved in a lot of interesting things from digital audio to aerospace. I was one of the people involved with the birth of what's now called private spaceflight, where Richard Branson decided to create his own rocket company, and now involved in the world of IoT and essentially the data that's generated by machines.
Perfect. And Johannes, can you tell us a little bit about your background and expertise as the CEO and founder of IoT Marketing?
Sure, Tiffany. So, well, first of all, I feel right at home here at the Embedded Tech Conference because I started in the mid-80s in the semiconductor division of Philips Electronics, building 8-bit microprocessors. We all thought that 8-bit microprocessor would go away. It's still a thriving market, and it's still a great microprocessor. But of course, embedded systems have gotten much bigger, and there are much bigger processors now. But I've worked in semiconductors for about 25 years in Europe, Asia, and here in the US. Built wafer fabs, worked in development, engineering operations in semiconductors, and have been doing sales and marketing for the last 10 years.
Perfect. Thank you, Johannes. And be sure to speak up so that everyone in the convention hall can hear us talking about the embedded systems of the future. And so, David, from your point of view, how have you seen embedded systems change over the past, say, 5 to 10 years?
Well, embedded systems tend to follow what's called Moore's Law. So for those of you probably all heard about it, Gordon Moore was the co-founder of Intel. He is widely regarded as the person who first predicted the evolution of the microprocessor. Essentially, he said that the number of switches on a chip would double every 18 to 24 months. Now that more or less equates to the power of the chip doubling every 18 to 24 months. What's astonishing is that Gordon Moore's prediction, now called Moore's Law, and the fact of it, and how that is tracked with his company Intel, has still continued to this day, and it's been 40 years since he made that prediction. It's very salient to embedded systems because we're now getting, what Intel calls the better, faster, cheaper waterfall chart of each new generation of processor. Now embedded systems have the power of, when Johannes was talking about working on 8-bit microprocessors, we're now up to horsepower levels that would have been just inconceivable, 10 years ago.
Excellent. Thank you so much, David. And Johannes, can you tell us from your perspective what embedded systems can do now that they never could before?
Well, looking at it from our webinars, Tiffany, so we are asking more and more from embedded systems because the IoT is pushing more intelligence to the edge. It's asking more analytics on the edge. And yes, for decades we could work with 8-bit. Now we need multi-core embedded microprocessor systems simply for the data processing, simply for the analytics, and even for cybersecurity. So it's just more that embedded systems have to do now. And it's we're getting to the point where we're pushing so much intelligence and also computing power to the edge that we are creating an autonomous edge where the data, because we're simply producing too much data. We cannot store all the data that we generate right now. So that data needs to be processed on the edge. The other thing is also, you cannot push all the data from the edge into the cloud. You don't have the bandwidth enough bandwidth to push it into the cloud. So we are creating autonomous systems on the edge that call into the mothership cloud on a regular basis simply to see if anything needs to be fixed.
Thank you, Johannes. And for anyone just joining us, feel free to come on up and grab a seat. We're going to need your opinion in just a second. We're going to have a poll. But David, first, could you tell us if you feel embedded systems are becoming more complex or more simplified?
I would say they're becoming fantastically more complex. Kind of tagging on what Johannes said, if you go back some time, all of this really evolved from the hardware side from what was called programmable controllers. So these were based on ladder logic programming. If you've been around, you might remember that. And this is where you would have controllers that might run a machine. This is way before it became something that we would use as consumers. It always started in the domains of industry, the military, and so on. What's fascinating now is that embedded systems aren't just a processor running code. It's complete little mini ecosystems. A great example is you probably have a smart speaker at home. Well, that's an embedded system of the highest order for the moment. It'll get fancier and fancier. And now because of the progression of Moore's Law, you now have the ability to run artificial intelligence in incredibly small devices. Probably the most important thing that's happened to embedded systems is the not embedded part, which is that we have cloud computing, we have very, very fast connectivity, especially with obviously wireless, but we also have not just short duration or short distance wireless like Wi-Fi and Bluetooth, we of course have the evolution of 5G. So 5G isn't just a faster way to do wide area connectivity. There's a lot of things in 5G that are starting to be implemented by the telcos around the world that let you do things like have your own channel. So you can say, well, I'm deploying a bunch of smart street lamps in a city, and there's AI embedded in each one of those, but they're also talking over 5G on their own dedicated channels to, we might call the mothership, the big cloud computing centers. And that augments the intelligence of the edge devices. That alone is a big advent for everybody. So when you talk to your I can say it here because I don't think the device is around, but the Alexa, I have 8 of them at home. So when I say Alexa, all these things go, pardon me, I didn't understand your question.
Oh, I'm sure Alexa knows you very well, David.
yeah, no, it's scary. Or, Siri, it's Google Home. Well, that device is just processing the speech. It's looking for the wake-up word. Then it says, oh, I heard the wake-up word, and then it buffers that, and then it sends it up to the cloud. But the fact that it changes all the time, it gets smarter and smarter and smarter, that intelligence is not in the embedded device, it's actually in the cloud, and that's why it appears to be like magically intelligent, or not so magical.
Great, David, thank you so much. And Johannes, as we talk about different embedded systems getting more simplified, how do you see the low-code and no-code revolution impacting the embedded systems of the future?
Look at the platforms that are being used right now. You can use C, everything dialect. You can use Java, Python, PHP. Most of the operating languages are being used already. And what's also being used is we're using MATLAB and MATLAB Simulink on embedded platforms. Now MATLAB Simulink is pretty low code. So what I'm trying to say is the environment is there, so we can run any local platform on embedded systems. And it will definitely help because embedded systems are getting more complex. So if you can accelerate the development cycle of software with low code, that will definitely help getting the device to the market that much faster.
And my next question is to the audience. Is everyone doing well out there? Well, my next question is, what do you see as being the next disruptor to embedded systems? Is it going to be AI? Is it going to be IoT, blockchain, quantum, any other technologies anyone wants to mention? Okay, well, what was that?
Hacking.
Hacking. Oh, well, that's very disruptive. All right. Anyone else have some ideas of what's going to disrupt the embedded systems landscape? All right. Well, oh, here's one.
Coronal mass ejection.
Well, you may have to tell us more. What exactly is that?
In a sense, that solar wind from the sun.
Look out for that solar wind, everyone. Seriously. I'll have to study up on that one. We talk about space a lot in our webinar series. So let's go by a show of hands here. Who thinks that AI is going to be the most disruptive? Anybody? Okay. What about IoT? Anybody? How about blockchain? All right. What about quantum? All right. What about solar winds? And hacking and hacking. All right. Well, I think hacking could also be very disruptive. But David, what are your thoughts on this? And which of those technologies do you feel will be the most disruptive and why?
Well, I think in terms of the sort of the ongoing march of all of this, definitely artificial intelligence. Most of what we call AI now, you've probably heard terms like machine learning, deep learning. These are parts of the AI landscape. The one that you're seeing and experiencing in your daily life, including in your car and your phone and so on, is machine learning, and it's basically what it sounds like. You're sort of like a child learning about something based on different attempts at it. What we don't have yet is what they call the generalized AI, or if you're a Star Trek fan, Commander Data. That would be where it just learns from scratch and just figures things out. There are lots of things at universities and some large corporations working on generalized AI, but things like your Amazon Alexa, it is not a generalized AI. It is trying to learn based on what it's hearing and then comparing it to a humongous array of databases and then trying to make correlations. And then as you respond, it's machine learning. It's saying, oh, I got it right because the customer said, yes, that's what I wanted. I will mention blockchain. So blockchain kind of got out of control in the hype cycle for a while. People were ascribing magical qualities to it. Blockchain will cure cancer. Blockchain will take you to the moon. It will not do any of those things. So the person who invented Bitcoin came up with blockchain because they needed essentially a mutable record that says something happened. I need to encode it in a way that is distributed and very, very difficult to hack. About the hackers back there. And very importantly, that anybody can audit. You have to have a key. So blockchain turns out to be really, really good at that, but it's not a protocol, it's not a programming language, it's not a database. It is a transaction record. That's super valuable to embedded systems because then you can actually create this record of what happened. So that was perfect for digital currency, but it's now being used, like we at Turbine are using it to keep track of data going from one entity to another, from an IoT device, say to some company. But then I'll wrap that segment up with this. Quantum computing has every possibility of breaking blockchain and almost every other cryptographic thing that we have out there. It is going to be incredibly disruptive.
Can you repeat that, David? The most disruptive by far is
quantum computing, because it will be able to, quote unquote, hack anything. It'll allow you to hack anything in ways that we're not able to even deal with right now. So there are people out there at government agencies around the world, universities, corporations who are actually worried about the counter to quantum computing. They're already worried about it, which is really interesting. But it's not going to be here next week, at least not for the average person to have access to.
Well, it sounds very, very disruptive. So there's your hacking, and there's one of those answers. But Johannes, can you tell us what you feel IoT's role will be in the future of embedded systems?
Well, as you've seen in all the webinars, the role of IoT is actually to push a lot of the applications to the systems. And the role of IoT is to really create intelligence on the edge and help basically our society with processing the data and developing new applications.
Great. Well, there you have it. There are the biggest disruptions coming to embedded systems. And David, when we look at something like autonomous driving, it seems like a lot of systems are going to have to work together in order to make this possible. What challenges do you foresee, and how does something like mobile edge computing come into play in solving those challenges?
Yeah, it's a great question. So first of all, a modern vehicle is just chock full of embedded systems. It's a very high-end automobile with lots of features, toys and things. Could have 300 processors in it. Most people are just blown away to hear that kind of a number. Now these are processors all the way down from a little microcontroller that runs your windshield wipers, all the way up to a big brain that's running your infotainment system. And even the infotainment system probably has a lot of processors all by itself, just to read the fact that you turn the knob or touch the screen. You know, a lot of this supply chain shortage stuff we're talking about right now in automotive, I think people have been finding it amazing that, you know, like GMC can't ship 10,000 pickup trucks because it's missing the control chip for the headlights. It's a real thing. So, and it's because it's so embedded, and I mean literally embedded into surface mount, you know, flex circuits and things like that. You can't just ship the truck without that and then go back and retrofit it later without a really expensive replacement of the entire, you know, possibly a whole motherboard that's worth, you know, $1,200 or more. So that is why the automotive industry got kind of used to things being delivered, you know, in essentially real time to the factories, and now, you know, that's where the impedance is occurring. So with automotive, these embedded systems do have a big range of sort of sophistication. And now it's bubbling up and bubbling up to where the vehicles now need to talk to something that's not the vehicle. So that's where mobile edge computing comes in. So edge computing, broadly defined, means that there's a processor, usually something that runs, you know, like a general purpose processor running, you know, an operating system that you can load applications into, and it's at the end of the sort of data supply chain. So a lot of people argue your phone is an edge computing device. Yeah, I mean, even though I can't load code on your computer, on your phone, that would be pretty scary. But the interesting thing is now with 5G, it's going to be possible to have what they broadly classify as mobile edge computing. So what that means is in the cell tower, there are going to be processors that can actually deal with applications as a vehicle or a person is moving in the vicinity of that cell tower. It's very, very interesting. In fact, this conference is taking place in Las Vegas. Las Vegas, very progressively, is installing mobile edge computing centers in the downtown district. They're actually just doing that at the moment. And you'll actually be able to load interesting things like software that helps fly drones, or software that delivers augmented reality images to glasses. They're all coming out. Or smart windshields that have displays. Really cool stuff. And that is where the processing is predominantly done in the cell tower. That way you don't have to have too much compute power and memory and mass storage on the device itself. So it's absolutely happening right now.
Exactly. How far away are we from seeing autonomous vehicles on the road, or are we already there?
That's a fun question. Turns out just yesterday I took a ride in an autonomous vehicle here in Las Vegas. These are not the Teslas running underneath the convention center. That's driven by a human, but at the moment. But around Las Vegas, 5 different companies are testing autonomous vehicles. They're very open to these innovations in Las Vegas. It's really neat. The one I went in is it was a BMW that was run by a trunk full of computers. There's a person in there as a safety driver. Next year, Hyundai will be testing fully autonomous electric vehicles in Las Vegas with no safety driver. So we're really, that's already been done in Phoenix. And so I think, you know, the issue with the autonomy running around a downtown area is very good now. I think the first place we'll see mass autonomous vehicles are going to be on the major interstate highways, and that'll be big rig trucks, because, you know, there's not likely somebody's going to kick the soccer ball into the middle of the freeway, but on a surface street, there's infinitely more variables. So that, again, is based on machine learning technology, more and more horsepower on board the vehicle. But yeah, big rigs, there's a company called Einride that's already doing testing of autonomous big rigs. And in Europe, actually in the area where Johannes is from, they're actually testing what's called platooning. And this is where there's a big rig in the lead driven by a human, which is really about the law at the moment. And then there could be 7 or 8 other big rigs that are following it like ducks in a row. And at the biggest port in Europe, Rotterdam, they just had big rigs from all different European countries all converge with, I think it was 5 big rigs in tow, and they all made it within about a 2-hour period from all over Europe with nobody driving the following trucks.
Johannes, can you give some advice for anyone trying to navigate Industry 4.0 and the exponential pace of change that we're dealing with?
Well, navigating Industry 4.0, we, we did a webinar in April called Earth 4.0, and that's our sustainability webinar this year. One of the conclusions of that webinar was that we really need to take a step back because Industry 4.0 is not good enough at the moment, and I'll explain in a sec. And because of the environment. We really need to take care of our environment. We really need to take care of sustainability with anything that we build. So Industry 4.0 is not there yet. We may need Industry 5.0 as soon as we can get it, because that has the sustainability component, or we need to adopt that and create Industry 4.5 with more sustainability. So that's one thing. What it means for anybody who's working in this space, more work, because there's going to be more change, going to be more adaptation. The other thing that's happening, and we also seen it in the webinars, our webinars are, we have an international audience. We have over 100 countries in the audience on a monthly basis. We see innovation happening worldwide. Second thing, and everybody has experienced that in the past year, a pandemic is a giant accelerator. So what we've seen as tiny trends floundering like blockchain before the pandemic now is a major trend with multiple impacts. So the pandemic is not over yet. It will continue to accelerate all kinds of developments. So yeah, hang in for the ride because it will continue like this. So the speed of change, as we've seen in the past 2 years, it will continue.
Well done, Johannes. I love that you're supporting the environment there. Such an important issue to highlight. And David, can you tell us maybe a prediction for what you see for the embedded systems of the future?
Well, there's a couple things that will just continue to get better, faster, cheaper. And again, it's not just about the cost, size, and performance of a processor. It's really going to be about the added sophistication of the software running on these things and the fact that they're going to be increasingly connected at higher speeds, which means that you'll be able to, kind of have shared intelligence, cloud to end device. I'm going to now address coronal mass ejection. So the sort of lay term for that is a solar flare. This is where the sun have these flares that come up that, if you've ever seen the films, are absolutely terrifying. No, you cannot fly the Enterprise through one of them, even though they did that in a movie. They're very, very scary things that are way bigger than the planet Earth. And then the sun's about 93 million miles from the Earth, and so by the time these things get here, they've been dissipated highly. But when they collide with our atmosphere, they create ionization, and that can really mess with radio signals, and does. So the last time, we just had a big one just recently, actually, here on Earth. And that will, just like hacking, it's something, and quantum computing, it's something we do have to worry about. We become so dependent on wireless. And the lower power of the wireless signal, the more it's likely that these things can interfere with them. Sometimes just for a moment, sometimes could even be for days. So as we become more and more dependent on wireless communications, we actually do become more vulnerable to things like solar flares, or in a very bad scenario, an electromagnetic pulse caused by a human device. Effectively, a solar flare is kind of like an EMP. So I think we do have to worry about this, and the idea is over time, critical systems have to be, what they, in the military, we call hardened. That means they're shielded against interference, and then you've got to shield them in the electronic domain against things like hacking and so on. That's I'll call it the glass half full. The glass half are empty. The full look is that the amount of power we're going to be able to have in incredibly small devices is going to be so magical to us, as we go forward in time. We're going to have AI at the most minute level, where your water faucet or something like that will know that, she's washing her hands with soap, so I need to turn the temperature up and the volume. No, it's just rinsing the toothbrush. Maybe we need a different volume and not to make the water so hot. And that sounds weird, but that's the kind of thing that really could be coming at us. if you guys want to see an amazing example of embedded systems in the consumer world, if you come back to Vegas in January, one of the world's largest conventions is the Consumer Electronics Show, and there are these halls, including the one we're in. They're just full of booths of companies from all over the world. Everything from Finland to Singapore, and the most entertaining thing is to find these booths that are a company you've never heard of, and yet they may be inventing the next really, really cool device that will definitely go on Amazon eventually. So I think the future is very bright for embedded systems, and I think over time it'll become indistinguishable from just everything around us.
Thank you, David. And the reason why David knows so much about solar flares is because he actually has a spaceship. It's true. You have to tell them about this, David. Come on.
All right, the spaceship. Putting me on the spot. Outside of Turbine, we have a nonprofit foundation that owns the last of the 3 space shuttle orbiters. Talk about a thing full of embedded systems. The space shuttle, this is Endeavour. If you go to LA, we have it on display. The space shuttle is comprised of 2 million components. It's everything from a little tiny, there's 23,000 individual space heat ablation tiles and lots of kind of old processors for, where we are today. If you want to see an example of the difference between the evolution of control systems, if you look at the cockpit of the shuttle, there's 1,500 buttons and knobs and displays in the cockpit of a space shuttle. There's all over you.
But are they all embedded?
Almost none. It's a pretty old design. But then you go in the new Dragon capsule, the Crew Dragon from SpaceX. It's just like a giant iPad, and everything is embedded systems. And so that the users just have to go like this, and there's a lot of AI that thinks about, well, this astronaut may need to know this because of what's happening externally, and it would literally just already predict that and put that on the screen in front of the correct crew member. So that's a really good example in a 30-something year evolution of spacecraft, of how embedded systems have become just part of the fabric.
Well, I'm sorry to put you on the spot there, David, but who could pass up the opportunity to ask about your spaceship? I mean, really. And Johannes, did you have a prediction for us as well as to the future of embedded systems?
Well, there's a booth here at the show, and they have a robot called Rosie, which is a garbage robot. Should have called it Wall-E. Of course, they cannot get that name because it's Disney and this planet, etc., etc. But I think that's where embedded systems eventually will end up, like autonomous systems, just hovering on the edge, doing the stuff, and just only reporting back if something needs to be fixed.
Thank you, Johannes. And from my perspective, some of the embedded systems of the future involve sensors that we'll eat, and then the AI will tell us how we can eat better food that's more in alignment with our body system. So that's what I'm seeing. You can also hear more about that on our Connected Food webinar on June 30th at iotmktg.com. But at this point, I'd like to open up the floor for questions. Does anyone have a question for our panel? Oh, I see 2 questions. All right, we've got time for 2 questions. All right, we'll start over here.
What is your prediction on pilotless commercial aircraft?
I love that question. So there's 2 things happening in aviation right now that are kind of, I hate to use this as a total pun, but below the radar. One is much like what's already happening in private spaceflight. We now have a lot of startup companies working in aviation that most people haven't heard of yet, but they're all working on autonomous aviation. I happened to speak to some people the other day who have a company called Elroy, literally named after the kid in the Jetsons. So they've got this well-funded company. They're partner with FedEx, and they're building autonomous cargo drones. If one were here, it would fill a lot of the area we're in. It'll pick up 500 pounds, take it, I think, at about 200 miles an hour at an altitude of 15,000 feet. And it's what's called an inline hybrid. So there's an engine that spins a drive shaft that runs an electric generator, plus a bunch of very high-tech batteries that are very lightweight. And they can deliver that cargo up to 500 miles. So 500 pounds, 500 miles, and it's just completely pilotless. There are a whole bunch of companies working in this. One's called Joby, one's called Archer. Uh, all those names, by the way, are like cute names based on science fiction and cartoons. Um, the One of the two founders of Google, Larry Page, has a company called Kitty Hawk. They're actually testing their vertical takeoff and landing machines right here in Las Vegas, over in Lake Las Vegas. So, and it's at the same time, there's a tendency to want to make these things electric. So the problem with batteries is we still don't have solid state batteries that are so light and dense in terms of energy storage that you can just, generation, that you can just have electric airplanes. But the autonomy isn't really coupled to being electric. It's just the fact that everybody wants to go electric. So the two trends are electric aviation and autonomous control. This is very different to what we've had for many decades, which is, of course, autopilot. These are things that tend to take off from a small footprint. They completely guide themselves from start to finish. Yes, a 777 can do that, but they kind of have to have a human, there hovering over it in case anything goes wrong. These new systems are so sophisticated with AI that they really don't, they're really designed to deal with many, many, many conditions and variables. I think the cargo, areas where we're really going to see it first, like Elroy, because then, they will definitely have crashes and you're not taking out a pilot or passengers. Kind of where does it go down is a different question. But all of the Elroy's flying, and like I said, FedEx is partnering with them, so you may actually have a big drone land in your neighborhood in the future and drop off your packages.
I believe we have a further update question. What is your name, sir?
Noel.
All right, Noel, what is part 2 of your question?
Part two. So you can't do that yet with the Boeing 737 or any of those passenger planes?
Well, any jet, pretty much any modern jet of any type, little ones, big ones, has very sophisticated autopilot capabilities. This, of course, started in military and with NASA a long, long time ago, and it's getting better and better and better. But sometimes it's a little bit too smart. So the issue with the 737 MAX that caused such big problems and controversy was actually a software issue, and they've given it so much control that the pilot couldn't take it back, and so it just unfortunately nosed over. These new things, out of adversity often comes great things. So because of the very, very public and disastrous issues with the 737 MAX, all the aircraft companies are really paying attention to this now at a level they might not have. But they're just all over it, and so are the regulatory agencies around the world. So I think, but it's true. If you're like in a Dreamliner, you literally pull up to the end of a runway at almost any airport in the world and just say, it knows where it is, and say, I'm going to Heathrow, runway 29 left, and it'll figure it out, know the weather, what the other planes are doing. But the pilots are still required. It really is a matter of safety if something fails, or something really weird happens that the software can't account for because it's not programmed in.
Well, I have several parts to that question I'd like to continue with, but for the sake of time, I know we have another question over here. So, what is your question? What's your name? And what is your question?
My prediction, do you have any predictions for investing, where to invest on IoT?
You start, I'll go.
Where's the money? Johannes, you're first up.
Where's the money in IoT? It's in AI, ML. That's where I would invest in. Is realize IoT is everywhere. It's all over every industry, and also IoT. It's not just the connectivity anymore. It's the application. What can you do by connecting your device to the web? So it's right now. Medical is still a good way to invest if you have the time, because medical is always hard. But anything where you can put an AI or an ML engine in a device, it will be a good point for investment.
Johannes, invest in our planet, right? Invest in our planet first. Okay, but where is the money? David, tell us your prediction.
It's kind of a bifurcated answer. So if you're a company or maybe a government agency, you're talking about investing in stuff. So obviously IoT is so pervasive. The real issue is, well, how do you do something useful with it that makes your capex, opex worth it? And increasingly, we're seeing more predictive analytics, things like that, generally based on artificial intelligence algorithms that will allow you to get better outcomes from everything from manufacturing to flying an aircraft. Then there's the other side, who's where do you invest if you're an investor and you want to make some money. That's right. That's right. It's the data. Yes, so our company Turbine is completely based on the idea that the data from machines needs to get to other places in a curated way that's it's controlled by a lot of sophisticated policies about who can do what to whom, under what conditions, where, when, and can you monetize that data? So the holy grail of the IoT is, can you monetize the data? And there's even a book called The $0 Car, written by a former, I think, GM executive, that says that eventually the data a car generates is going to be so valuable it'll pay for the car. I personally don't think that would really be a lot, but the idea that we're going in that direction, that the data becomes the most valuable attribute of something, we're definitely going that way. And I think over time you'll see more and more of these sort of alliances being formed in different industries to allow the data to move back and forth, and therefore, once you've done that, you can monetize it.
And I feel that's why 75% of IoT projects are failing, is because they don't focus enough on the data. Johannes, is that what you're seeing?
Yes, because we're producing so much data right now, it's hard to analyze, and then of course you need to trust the data that you collect. One of the big problems, and it's a company culture thing, but one of the big problems that we're seeing is that yes, companies are connecting everything to the internet, yes, they're collecting the data, yes, they're doing analytics, but then they don't believe the numbers that they are seeing. So it's with the data, you have to have the analysis. You also have to have a plan. What am I going to do if a device fails? What's the procedure? You have to make the switch to the data economy, and we're just at that inflection point where we are heading towards a data economy. So yeah, learn to trust the data.
Don't forget about the hackers, because they are out there, so you have to prepare yourselves. Any other questions before we close things up today? All right, we do have one last question. What is your name?
My name's B.
All right, B, what is your question?
I'm a local here in Las Vegas, and when it comes to smart cities, the data that they use when they plan the city is they wait for a commercial developer to develop two plots against each other, then they have that developer pay for the street light. Well, in the meantime, while those lots are vacant, there's a bunch of accidents. So they basically are only driven by revenue. How do you plan to partner with different cities to make those smart cities a reality when there's not really an avenue that they can see in their landscape?
Powerful, B. I love the question. David?
Sure. Well, it's kind of generally known that just saying smart cities, there doesn't seem to be any money there. So, and a lot of people think the cities will pay for the smart city part. But a smart city is a lot more than the street lamps and traffic. The issue you're bringing up is, well, it does have to do with things like commercial property development, a lot of other things. There are a lot of issues that are kind of coming to the fore more in Europe than the United States right now about making properties safer and, more importantly, sustainable. The United Nations has put out a thing called Sustainable Development Goal 11, which they actually have said in this incredible statement they want to have 10,000 cities around the world adopt SDG 11 over the next decade. And that will literally be where all the different parts of a city talk to each other, and it'll go all the way back to the planning process. I think the biggest obstacle right now is that the regulations, the statutes, policies, all of those things have not kept up with the technology. And that's pretty typical. The government doesn't keep up with technology. I do think we're going to see some of that start to happen, but it's going to be city by city. There's probably not going to be some mandate, even in Europe where they can do it across a smaller footprint in many countries. It's going to be done really at the individual city level.
Well, thank you, David, and thank you, Las Vegas. Thank you, Embedded Technology Convention. Thank you, all of you, for joining us today. Thank you, David, Johannes, and I hope everyone has a wonderful day. I hope you found this convention informative as well as this panel. If you want to continue learning, tune in for our Industry Insights webinar series once a month, the end of the month, last Thursday of the month. You can learn about all these topics and more, and you can register free now at iiwcommunity.com or iotmktg.com. Thank you. Have a wonderful day.